Hi, I'm Thomas, also known as Cloudowski, and this is first webinar of the series that I called Let's Talk Platform Architecture. During these webinars, I will cover topics related to platform engineering and more specifically related to I will talk about how to design a good platform for your applications, what strategies and tactics to use, what tools are available and recommended for particular use cases, and many, many more. So this first webinar is about OpenTelemetry and observability as well. So let's start. Let me just introduce myself for those of you who doesn't know me. So I'm Thomas, also known as Cloudowski, like I mentioned before. I am platform or DevOps architect because those topics are a little bit confusing. However, I've been working as a platform DevOps architect for many, many years. I also provide training mostly around on Kubernetes, including master classes, dedicated workshops, and so on. I've been helping companies as a trusted advisor to help them to build modern platforms and embrace this new approach to designing and running cloud native applications. When it comes to technologies, I I really, really love Kubernetes. However, um, I know that in complex environments, technology is just not enough. I found out that you need to adjust your tools, adjust your technologies, and use those in your organization context with different needs and different goals. Okay, but that's about me. Let's move on to our main topic. Um, when it comes to monitoring or observability, back in the day, it was pretty simple, especially if your environment was built from monolith applications. So if you had monolith application, in order to gain some insight into your application, you probably all you needed to do is to have some APM, application performance monitoring agent, running alongside with your application that would send some traces, metrics, and maybe even logs to your APM system or a platform. When it comes to monitoring or other metrics, of course, there were and still are some systems built to just to gather metrics and perform some operations, including raising some alerts, for example. But when it comes to logging, for example, we had various solutions, including those simple, very simple ones like browsing your logs directly on the server that the app was running on. So we had multiple vendors, multiple protocols, methods of getting your logs, metrics, and so on from your applications. So that was past. And how does it look like nowadays? Well, of course, everyone wants to have only microservices. However, in especially in larger environments, you have alongside with your microservices, you have also some monoliths as well, because legacy software is still present in many organizations. So those applications, they run on virtual machines, maybe even bare metal servers, and of course, most of them probably are running inside ephemeral containers. So all of this creates a system that is distributed. So connectivity between those microservices, between monolith applications, well, it's becoming really, really complex, and especially if you're using not only cloud, but you're using your on-prem environment, you're using Kubernetes or OpenShift or any other container orchestrator. And additionally, some organizations decided to implement, on top of that, implement service meshes. Service meshes, when it comes to observability, are pretty good thing. However, not the best one. And I will cover that later on, why service meshes service meshes aren't really that good for implementing full observability in your platform. And this makes current environments really, I mean, really, really complex when it comes to gaining some insights uh, in order to, well, let's see what we want to have from our current environment. So in this in so complex environments, we really need observability. Why? And what is observability? First of all, the main role, the main job of observability system, observability components, is to collect signals from your system. And by system, I mean a bunch of applications, like dozens or hundreds of your microservices, your legacy software also running somewhere, and also some parts of your system, like, for example, Kubernetes controllers, that also sometimes can cause some issues, can even cause some outages. So those signals need some context, and that's why observability platform needs to add some context, some additional information for just for recognizing which part of your system is malfunctioning or misbehaves. So, what kind of signals do we have in observability? We have spans or traces. Span is a unit of work performed by your application. So, this could be accepting your request, performing some, I don't know, internal logic, like transforming your data, or communicating with some other service. And those spans can be combined into something we call traces. And those traces can include spans from multiple applications, for example, from multiple microservices and your monolith or legacy software running inside your platform. So the next signal is probably very, very well known for most of you, because we are familiar with logs. Unfortunately, logs, when it comes to getting some information from them, are in most cases they are just plain text, lines of some information. And fortunately, more and more organizations started to implement structured approach to logs. So instead of sending plain text, we just need some structure to those information, and that's why we often call these logs events, just simply events. And of course, metrics that we can use to performance tuning, or actually to keep our system fast enough, or at least or for example, or at least to track down bottlenecks, which will always be somewhere. And with proper observability, you are able to track them down, to pin down to the specific microservice or some component of your system, or even a piece of code that underperforms, just basically. But observability is not only about performance tuning, of course. It's about troubleshooting. It's about helping you to really dig into your system, to gain some insight, like I mentioned, and to address the unknown unknowns. It's not about fancy dashboards that are static. It's about having possibility to track down your system to this very tiny pieces of code, or pieces of information that are sent between those components of your system, including for example, Kubernetes components as well. Okay, so that's it. Moving on. So what is OpenTelemetry anyway? So OpenTelemetry is an open source project. And I like to compare it with my favorite open source project, which is, of course, Kubernetes. So just like Kubernetes covers or hides the complexity of the infrastructure that is used to run your applications, OpenTelemetry hides or creates this abstraction layer for observability. It just tells you what kind of signals you can fetch, you can receive, and how to handle them. So it's also a specification. It's a API, versioned API, just like Kubernetes API, and a set of SDKs or libraries for specific languages. But that's not all. OpenTelemetry includes this very, very important piece of software, piece of kind of component, which is called OpenTelemetry Collector. I will cover OpenTelemetry Collector in a few minutes. But OpenTelemetry also includes its own protocol called OpenTelemetry Protocol, or OTLP for short. But let's dig into OpenTelemetry Collector, because this is very crucial part of OpenTelemetry. So OpenTelemetry Collector is a software that you need to, or if you want to implement OpenTelemetry, you need to install somewhere on your platform. And it collects signals from multiple sources, like your applications, like various even databases, even your cloud platform. It receives your data by using small pieces, which we call receivers. So OpenTelemetry is a modular software and has many receivers. I will mention that also later on. So it can receive data from multiple sources in multiple formats, including, like you see on the diagram, Prometheus, Jaeger, or native OTLP protocol. So there are dozens of methods or formats that OpenTelemetry Collector is able to accept. And what happens then? OpenTelemetry is able to process your data, process your signals, to ensure, I will cover that also later on, to ensure that, for example, no confidential data is sent to your backend, or, for example, to create some batches of data instead of sending them in a single request, or actually send them in a single request instead of many ones. Okay. OpenTelemetry Collector has also extensions. Extensions are used mostly for authentication. So if you want to send your data somewhere else, and you need to send it somewhere else. Maybe you need maybe you need to authenticate against your backend, and that's why there are various ways that you can use to authenticate. Okay, and finally, OpenTelemetry collector includes exporters. Exporters are also tiny modules inside OpenTelemetry collector project that are able to send your data to multiple backends. And there are there are around 50 exporters available at the time of the recording of this webinar. And as you can see, you can send your logs, traces, and the metrics to well-known products or projects like, as you can see, Grafana, like Splunk, like Dynatrace Datadog, or services available on your cloud provider. Okay, so this is really crucial. OpenTelemetry collector. I will mention that also in a few minutes. And of course, this OpenTelemetry protocol is also a part of OpenTelemetry ecosystem. It is well-defined protocol for transmitting data, for transmitting signals actually from your system, from your components. So OpenTelemetry collector can receive data using OTLP protocol, but as you've seen already, it can also accept data in many other formats as well. And it can also send your signals to your backends using this OTLP protocol or some proprietary format or protocol as well. Fortunately, more and more vendors like Grafana, like Datadog, and others as well, they accept observability signals in this native OTLP protocol. So it looks like this OpenTelemetry is going to be really popular. I'm hoping that it will. Okay, but one more thing about OpenTelemetry. OpenTelemetry is not a product. It's an open source project, just like Kubernetes. And there are many volunteers working on this project, but it's very good about the idea that it's an open source project. There are also many vendors working on this API specification on OTLP protocol, just like with Kubernetes. And as we've seen already, it can produce a really well designed system. So it's not a product, but it doesn't have any user interface, any web interface whatsoever. So unfortunately, if you want to have like really nice interface for browsing your data, you need something else. You need backend, because OpenTelemetry, especially OpenTelemetry collector, is only a part that accepts and process your data. But in order to browse your data, in order to perform some troubleshooting or performance tuning, you need some backend. And OpenTelemetry doesn't have any backend for that. So you still need some product or open source project in order to browse your logs, metrics, and traces. Okay? Okay, moving on. Who needs OpenTelemetry? Let me just say that OpenTelemetry can be overwhelming for really small projects or really small organization. If you work for some startup, maybe sticking with some well-known open source project like Prometheus or Grafana stack maybe it's a better choice. However, for larger organizations or for more complex environments, it can become really, really useful to implement observability with OpenTelemetry. Why? For those larger environment, like heterogeneous environment, you may want to unify your observability, your approach to observability, to be precise. So with hundreds, even components, with different languages, different teams or departments maintaining and improving your code, your part of your parts of your system, it's really cumbersome. It's really difficult to have your full observability. So with OpenTelemetry, with so many modules, with so many ways to accept your signals and to send them to your chosen backend, OpenTelemetry is a really nice piece of software that can help you with that. And of course, with OpenTelemetry, you can still use existing products or projects, because in larger organizations you may have not only a single solution for storing and browsing metrics, but you can have many. uh, it often happens, and that's why with OpenTelemetry you can maybe even reduce the number of platforms used for observability as backends, of course. So that's that can also be used for migration between those different backends. You can switch from open source projects to some more convenient product, or from different product to another product. it it is very easy because of this vendor agnostic approach that OpenTelemetry brings. However, you can also start implementing the full observability with OpenTelemetry before deciding on which backend you want to choose for your platform. So you can start working with the specification included in the OpenTelemetry project, and then choose, maybe start with some simple open source project, and then easily, by just switching your toggle, um, easily transit, migrate to another backend. And besides, you can still have your options open, just like with Kubernetes. I know that's not that easy with Kubernetes running on a particular cloud platform, and migrating to another one. With Kubernetes is just easier, not super easy, but it's just easier. And the same goes with OpenTelemetry. Okay, one important thing that OpenTelemetry brings is standards and best practices. Because OpenTelemetry is well documented standard, you can refer the standard to your teammates or other teams in your organization, and agree on OpenTelemetry, on observability standards that are defined in OpenTelemetry specification. Especially if you have this is really important. This context propagation is especially useful if you have bunch of microservices and even monoliths distributed across different clouds, on-prem, Kubernetes, and so on and so forth. With OpenTelemetry, finally you can agree on this very specific standard for implementing tracing, for combining all these spans from different languages into one standard that can be then browsed, of course, on your chosen backend. And there are many interesting features of OpenTelemetry, like sampling, like data obfuscation, that I will mention later on. But moving on to best features of OpenTelemetry. So let me just say that it's not a comprehensive list. It's just my list of the things that I consider killer features of OpenTelemetry and why you may want to consider implementing that on your platform. This is really awesome. Seriously. Auto instrumentation. Just imagine that you have your applications working on your Kubernetes cluster or on your cloud using on cloud instances, virtual machines, and you just run your application with some wrapper, with some wrapping script or kind of piece of software which OpenTelemetry provides. And this enables you to get tracing, to get logs, to get metrics from your application without modifying a single line of code in your application. Seriously, it's all about wrapping your application around some piece of software that OpenTelemetry provides, uh, of course, specific to the language that you use. And by doing so, OpenTelemetry can intercept your logs, can create spans and traces, and of course it can create or actually it can intercept or create some metrics as well. Let me just emphasize it once again: without doing anything with your application's code. It can be even legacy software, of course, provided that it is written in some modern language. That's just awesome. And I believe that it's far more better having this auto instrumentation. It's far more better than getting signals from service meshes. Yes, service meshes operates on a high level, or on particularly for web applications, it operates on layer 7. Just compare it to level in which OpenTelemetry is able to intercept calls produced by your code. It can create spans. Of course, service meshes can also produce spans, but it's a totally different game. So auto instrumentation is this killer feature of OpenTelemetry. And if you're using Kubernetes, it is far more easier with Kubernetes, because OpenTelemetry provides a Kubernetes operator that is able to install OpenTelemetry collector, but also enables this auto instrumentation for your applications. That's right. I've used it, and it works pretty well. When it comes to Kubernetes, this is another awesome thing when it comes to OpenTelemetry. Just imagine you install OpenTelemetry collector as a container, as a pod on your cluster, and then you are able to send your metrics directly from your Kubernetes cluster to some backend. You can, including metrics from your applications, but also from your Kubernetes components, like control plane components, like scheduler and various controllers as well. You can also send logs from your Kubernetes cluster, including logs from your containers, but also logs from your components. So logs from scheduler and operators and any kind of piece of software that you have running on your Kubernetes cluster. You can also include signals from your objects. So your object's state, which was which is, of course, it's possible nowadays, but you need to install kube state metrics, so additional component. While OpenTelemetry collector has this feature built in. you can get more insights, more information about your nodes, including things like Kubernetes specific things like conditions. Like, for example, if a node gets memory pressure or peak pressure, of course, OpenTelemetry collector also receives metrics, logs, and so on, just like with other components as well. That's not all, because I'm not sure if you know, but events from Kubernetes, they are discarded after 1 hour. So, in order to browse in order to browse older events, you need to archive them. You need to send them. And OpenTelemetry collector can do it for you, can send your events to your backend or backends in order for you to browse, in order for you to help you troubleshoot your system. And that's the beauty of it. It can do it with just a single component. You don't need any Splunk. You don't need any Prometheus exporters, even as sidecars. You don't need those, because OpenTelemetry collector is a single piece of software that you need to perform to get all these signals from your platform, of course, running on Kubernetes. But that's not all. We also have cool features when it comes to data processing. So OpenTelemetry has multiple processors that can process your signals in order to achieve some goal. Like, for example, like I mentioned, obfuscation. You don't want your logs, you don't want to expose confidential data that are sometimes produced in logs or some other signals. You want to obfuscate them. You want to hide them and to make it secure, to make sure that unprivileged users from your organizations are not able to see them, to browse them. Okay, but another thing is data sampling. Do you really need millions of almost identical logs, or almost identical spans, or almost identical metrics? Probably not. So data sampling is a really useful feature that is provided and handled by the OpenTelemetry collector that reduces noise. And it's really, really awesome. So by using complex techniques, OpenTelemetry collector can send only a subset of your metrics, only those logs that are useful or that are different. So there are many ways to achieve this sampling, but I consider it a very, very useful feature, especially for larger environments. And of course, OpenTelemetry can transform your data. You can filter out, you can add some additional context to your signals. And last but not least, OpenTelemetry collector can buffer your data. So instead of sending or initiating a connection to your backend whenever a log entry is produced, OpenTelemetry can create a batch of, I don't know, a thousand of logs or 1,000 of metrics and send it in a single connection. And of course, when there's a connectivity issue or maybe some outage of your backend, it can, of course, retry and send it as soon as your backend is up again. Okay, modularity. So OpenTelemetry, like you've seen before, is modular. So there are 4 types of modules included in OpenTelemetry collector, to be precise. So first type is processor. Processors can be used for sampling, like I mentioned, for grouping, for filtering, or for adding context. And there are um, over 20 processors available for such things. And as you can see, there are almost 100. There is 100 receivers that can accept your data from various sources. This is not a complete list. However, the ones that I find useful or sometimes even funny is that, of course, OpenTelemetry can accept data from your syslogs. So you can send data from your even some legacy Unix systems. Of course, there are some receivers for Datadog, for Oracle. Yes, for Oracle, including databases, and things like SNMP for network devices, or commercial products like Splunk. When it comes to extensions, extensions are useful. Are used, like I mentioned, for authentication, for encoding, or, which is also a very nice feature, for limit the usage of memory on your OpenTelemetry collector. Pretty cool feature. And the last part, exporters. There are almost 50 of them. Once again, this is not a complete list. You can send your data back to your syslog, but you can send your data to Kafka, to Dynatrace, to Loki when it comes to logs, or to Splunk, and many, many others. And this list will probably grow in the future, because OpenTelemetry is gaining so much popularity these days. Okay, but it's not that great, to be honest. It's not that great. And there is a reason why I haven't covered OpenTelemetry up till that point, because when I checked OpenTelemetry, when I was doing a research a few months ago, there were still there were some things that were during active development, and unfortunately there are still some parts that are under development. Let's see what parts. So if you want to use this auto instrumentation thing, and you're using one of those languages like Java, like .NET, like even PHP or C++, then you're fine. That's great, because all these languages have OpenTelemetry support for auto instrumentation and custom instrumentation as well. These features are considered as stable. But languages that are not that old or not that new as well, like Golang, like Python, like JavaScript, as you can see, of course, tracing and metrics, they are supported as a stable feature. However, logs are either in development or are considered as an experimental feature. So it's not that bad, because with Python, I was able to create a working configuration, and it's a decent working logging solution. But still, I'm hoping that in a few months we will be able to use it as a stable feature, not an experimental one. And for Go, we will be able to use a logging feature um, in general. Yes. Okay, that's not all, because some people may not want another additional abstraction layer. And I understand it. We have so many abstraction layers. And this is a new thing to learn. Yes, this is a new thing to learn. However, I think that it's a new technology, new abstraction layer that is worth learning, because you gain, finally, you are able to have full observability of your platform, um, especially with auto instrumentation. And moving on to the last part, how to start using OpenTelemetry. Well, that's pretty straightforward. First, you need to provision OpenTelemetry collector. And once again, if you have Kubernetes in your environment, you can just use OpenTelemetry operator, and it's pretty easy to install it. But if you don't want to use Kubernetes, you can install OpenTelemetry collector or on any kind of Linux server. So, what next? Next, you may want to use this awesome auto instrumentation feature. It's really, really easy. It takes, I don't know, a couple of minutes, maybe an hour, to set up your auto instrumentation for supported languages, and then you are ready to send your data to your chosen backend, and that's why you need to configure your exporters, and it is also pretty easy, and it's also pretty well documented in OpenTelemetry documentation. So all these 3 steps are pretty easy and pretty fast. However, the 4th one is not that easy, because it involves long discussions in your organizations, maybe some POCs, in order to enrich your observability signals and unify your approach to observability. But I think it's worth in the long perspective, um, and you will gain really, really deep insight into your system. And that's it. Thanks for watching. Let me know what do you think in the comment section below, or message me directly or via email. If you have any questions or you need help, just let me know. I'm planning to host more of these, like I mentioned at the beginning. So if you have interesting topics that I should cover, also please let me know. So see you next time, and bye.